Hey there and welcome. Today we're diving into the incredible cosmic clockwork that pretty much runs our lives. We're going to uncover the two fundamental motions of our planet that give us everything from our daily routine to the changing seasons. So let's get into it.
So, have you ever really stopped to think about that? How is it possible that for someone in, say, New York, December is all about snow and scarves, but for someone in Sydney, it's time to hit the beach? The answer isn't as simple as you might think. It's all part of this beautiful, predictable dance our planet is doing, day in and day out. All right, here's our game plan. We'll start with Earth's two main moves. Then we'll zoom in on that 24-hour spin that gives us day and night, followed by the year-long journey around the sun. But the real secret sauce, the thing that changes everything, is the Earth's tilt. And that's what leads us to the grand finale, solstices and equinoxes. Okay, so it all kicks off with two totally distinct but simultaneous motions. If you can get your head around this fundamental dance, everything else we talk about today will click into place. So let's get these two key ideas straight. First up, you've got rotation. That's just the Earth spinning in place on its axis, kind of like a top. This is what gives us day and night, and it takes about 24 hours. Then you've got revolution. That's the Earth's much, much longer journey, its orbit, all the way around the sun. This is what defines our year, and as we're about to see, our seasons. All right, let's zoom in and focus on that daily spin first. You know, the one that basically dictates our entire day-to-day life.
This image shows it perfectly. Think about it. The Earth is a big sphere, right? So the sun can only light up one half of it at any given moment. As our planet spins, we move across this line, this circle of illumination, passing from the bright, sunlit side into darkness, and then back into the light again. Day, night, day, night. In that full spin, one complete turn on its axis takes, you guessed it, about 24 hours. There's actually a cool official name for this period, Earth Day. It's the daily rhythm of our planet, the beat that sets our clocks in our lives. And get this is not some recent discovery. The ancient Indian astronomer Aryabhata laid out this simple but totally profound fact centuries ago. It's just a great reminder that people have been looking up at the sky and figuring this stuff out for a very, very long time.
Okay, we've got the daily spin down. Now let's zoom out from our 24-hour cycle and look at the much bigger picture, Earth's annual trip around the sun.
So, that year-long journey is what we call revolution. Earth is traveling along this set path, which is a little bit oval-shaped or elliptical. But look closely at how long it takes, 365 times and a quarter days. And that little quarter of a day? Oh, it's a huge deal.
So you might be wondering, what happens to that extra quarter day, those 6 hours every year? Well, for 3 years, we kind of just ignore it. We let it build up in the background. But after 4 years, those 6-hour chunks add up to a full 24 hours. And to make sure our calendar stays perfectly synced up with the cosmos, we add that extra day back in. We call it February 29th. And just like that, you've got a leap year.
Okay, let's recap. Rotation gives us day and night, revolution gives us the year. So what about the seasons? Now this is the part that blows most people's minds. It has almost nothing to do with how close we are to the sun. The real reason, the absolute game changer, is the tilt.
Yeah, our planet doesn't spin perfectly straight up and down. It's actually leaning over at a constant angle. And this is the most important part. That tilt stays pointed in the exact same direction in space the entire time it's making its year-long journey around the sun.
So here's where the magic happens. Because of that constant tilt as Earth orbits, for part of the year, the northern hemisphere is leaning towards the sun. Think of it like tilting your face towards a campfire. You get more direct, concentrated heat, right? That's summer. Then 6 months later, when we're on the other side of the sun, that same hemisphere is tilted away. The sun's rays hit it at a slant, they're more spread out, and deliver less heat. And that is winter.
And if you want the perfect real-world proof of this, think about Christmas. While people in the Northern Hemisphere might be dreaming of a white Christmas, folks down in Australia are celebrating with barbecues on the beach. Why? Because in December, it's their hemisphere that's tilted towards the sun. It's their summer.
Now, this tilted journey isn't just a smooth ride. It creates 4 really important checkpoints in the year that you've definitely heard of, the solstices and the equinoxes. Let's take the trip together, starting around June 21st. That's the summer solstice. The northern hemisphere is at its maximum tilt towards the sun, giving us our longest day of the year. As we keep orbiting, we hit the autumn equinox in September. Here, the Earth is tilted kind of sideways to the sun, so things are in balance. Day and night are nearly equal. Then we get to the December winter solstice. Now the northern hemisphere is tilted as far away from the sun as possible. Hello, shortest day of the year. And finally, we swing around to the March equinox, another moment of balance, right before we start heading back towards summer again.
And if you ever get these two mixed up, here's an easy way to remember them. Solstice comes from Latin words that basically mean sun stands still, and that makes sense, right?
It's when the sun reaches its highest or lowest point for the year. It's a day of extremes. Equinox, on the other hand, literally means equal night. It's right there in the name. It's all about balance, when day and night are pretty much equal all over the world.
So let's end with a big what if. Just imagine for a second that our Earth had no tilt. What would that world be like? Well, for starters, there would be no seasons. None. The equator would be scorching hot all year round. The poles would be permanently frozen solid, and there'd be these narrow, unchanging bands of weather in between. No spring, no summer, no autumn, no winter. It's that simple, constant tilt that creates the dynamic, beautiful, ever-changing world we get to call home.